All right, for part B, we have y equals x to the power of 2/3 and y equals 4. So why don't you go ahead and have your graphing calculator graphing two functions, in fact. One is x to the power of 2/3 and the other one is like 4. That's a horizontal line. And please graph it and see what it looks like. And I'm going to show you what I got here. So here we go. So the red curve here, which is the horizontal line, is just y equals 4, and the blue curve, we have two branches of that, right? That corresponds to y equals x to the power of 2/3. Okay, so we're trying to find the center of mass, and as you see that this graph, this region, is symmetrical about the y-axis. So we know that the center of mass is going to be somewhere on the y-axis. Okay. So it should be somewhere here. So if you want to write down the coordinates of that, well, for sure we know that x coordinate is going to be 0. Okay, we just don't know what the y coordinates should be. Again, this is something that we see from here, that this region is symmetrical about y-axis. So the center of mass, since we have like homogeneous density all over the planar lamina, right? So we should have somewhere in the middle on the y-axis, but we don't know exactly what the y coordinate of that. And at this moment, I want to remind you the formulas here. So you are supposed to calculate m sub x, the moment about x-axis. Okay, we have to calculate m sub y, the moment about y-axis, and the total mass, which is rho times the integral of f minus g from a to b. So our task right now is to find a and b and label f and g and try to do all calculations to come up with x bar and y bar eventually. Okay, and remember that x bar and y bar are independent of the density rho. All right. So since we have the top function to be y equals 4, so this is going to be our f. Okay, so this is going to be our f. So I'm going to call this to be f of x. And I'm going to call this guy to be g of x. Okay, so because in the actual formulation of the moment and center of mass of a planar lamina, we always start with f being greater than g, okay? F being greater than g, and in this case, f has to be 4 because 4 is the horizontal line making up the top bound of the yellow region, all right? So a and b should be the x and y coordinates here. So how do we find them? So we can actually check this out, okay? So we will set the y values equal for each function. So in other words, we're writing x to the power of 2/3 is equal to 4. Okay, so if I take the 3/2 power of both sides, then x becomes, because x to the power of 2/3 to the power of 3/2 is x to the power of 1. This is 4 to the power of 3/2 here. Okay, so that is 4 cubed in square root. That's radical 64, which is plus minus 8. Okay, so you should probably put here plus minus 8. Okay, all right. So here we go, minus 8 and plus 8. Okay, so these are the x min and x maxes. And you can also graph these functions for x equals -8 and x equals plus 8 for x min and x max. You should have already done that, but please get exact output that I got here. Okay, so why don't we go ahead and work through these integrals here. Okay, so let me just work everything in this slide. Let's see if I have enough space here. So m sub x here is rho. Oh, by the way, following my comment about the symmetry of the region, so we do not need to know m sub y divided by m, because m sub y divided by m has to be 0, because the x coordinate of the center of mass is already 0 here, as I mentioned. Okay, 0, and then we're trying to find y bar. Okay, so we're going to only do the calculation for y bar that requires m sub x only. Okay. So let's do that. Rho integral from -8 to 8. Okay. And m sub x, so, well, f is 4g equals x to the power of 2/3. So 4 plus x to the power of 2/3 divided by 2. That's f plus g divided by 2. And 4 minus x to the power of 2/3 dx. Okay, that is what we have here. Okay. And I also have m, little m. That's rho integral from -8 to 8. Okay. And that's f minus g, 4 minus x to the power of 2/3 dx. Okay. All right, let me just continue right here. But one observation here is that if you multiply 4 plus x to the power of 2/3 by 4 minus x to the power of 2/3, you're talking about the difference of squares. So that should be 16 minus x to the 4/3, okay, divided by 2. So m sub x okay, 16 minus 1/2, 16 minus x to the 4/3 dx, okay? And you can integrate that as like rho over 2, 16x minus x to the power of 7/3 divided by 7/3. Okay, that's us using the power rule for integration from -8 to 8. Okay. And let's do the calculation for little m. So that is rho 4x minus x to the power of 5/3 divided by 5/3. Okay, so rho and 4x x to the 5/3 divided by 5/3. Okay, lots of integrations. All right, so this is from -8 to 8. Okay, please go ahead and just do those calculations. So m sub x is supposed to be 5/12 over 7 rho, and then m is supposed to be 128 rho divided by 5. Okay. I skipped this because this video is already long, so please plug in the upper limits and plug in the lower limits and use the fundamental theorem of calculus to get down to those numbers. And hopefully now we can write y bar. We know that x bar equals 0, by the way, because the center of mass is on the y-axis. And you can go ahead and calculate that if you want to, but you'll end up being 0 for m sub y. M sub y divided by m would be just 0. Okay. So y bar out of this is going to be m sub x 5/12 divided by 7 rho divided by 128 divided by 5 rho. And as I said, rho is not a big deal in terms of calculating the center of mass because you're gonna this is rho. You're gonna sort of like cancel rows out. Cancel rows out. Okay. To conclude that, and if you simplify this on your own, you should get down to 20/7. All right. Let's go back to the picture here, and we know y bar, that is 20/7. So I can place that in. And 20/7 is 3 point something. That's obviously less than 4. 4 is the upper limit here. So we're close to the upper border of the lamina. And then, as I said, if you put a hook to that red dot over there, let me just clean that up. Red dot. Okay, if you put a hook and if you just lift the planar lamina up, so that planar lamina should just stay flat as is, okay? That's what the center of mass means. All right, so I'm gonna stop here, but we still have part C. Please move on to my next video to see what I'm gonna do for part C.